Just so you're all aware, we'll begin now, and I'm going to record this, and then I will post it on the Canvas. Um, it'll be posted on Canvas in some fashion, either just directly. I think I have enough space to throw a lot of video up there, or I'll put it up on my YouTube channel. All right. Incidentally, I'm not like advertising some YouTube channel where I am some content creator. It is just a bunch of recordings from the pandemic years. So it's not an interesting YouTube channel at all. It is just like hours upon hours of unedited classroom lecture video that just looks just like this. The sound quality is kind of shit because the microphone's right here and I can't not walk back and forth. So I'll fade and get quiet over here. Then I'll be facing the camera again and it'll get louder. But at least the stuff what's get written down here, that'll get recorded. The benefit was some students that were in my like the pandemic era and zoomed into classes, they got in-person class with me. It's like, oh my God, this guy is so much worse when you have to watch him at 1 time speed and not 2x speed like normal. And like, so a bunch of students were like, oh, where's the button to make this guy go at 2x speed? There isn't one. I'm just always this slow. All right. So what I have posted, it didn't get posted yesterday. Sorry about the delay, but it is posted there now. You'll find an announcement with a link to a document in the file section on the Canvas, which is this document here, which is your practice final exam. So here is how you're going to practice the final exam. And here's a simulation of what it looks like. And I'm going to talk about what we need to do. So, yeah, let's just do some problems. In problem 1, we're going to solve the triangle. What we want to notice is that if both triangles in problem number 1 are solving right triangles. So this is the solving right triangle style of problem. Problem 1 is solving right triangles. This means that our tool set is the acute angles are complementary, and we have the Pythagorean theorem, and we have opposite adjacent hypotenuse. So those are the things that we have available here. So angle alpha is 37.1 degrees. So I'm going to label that down here. Side C is 15.2. So I'm going to label my givens. And then I'm going to label what they are. The 15.2 is a hypotenuse. I can call that a hypotenuse because I have a right angle. And so now we're ready to proceed. Although I've listed things in an order, find side A, angle beta, and side B. I'm just putting things in alphabetical order. We can find these things in whatever order we want. In particular, we probably want to start with angle beta because when we have two angles, we can subtract to find the third angle. So I'll start with beta because that seems wise, and I'll just do 90 minus the 37.1. For some reason, when I wrote this, I put little boxes for all your answers. So angle beta 52.9. It was the second thing listed. It's not the first thing that we had to find, but it's the easiest thing to find because we just get there by subtraction. So now we have two angles, so we can use whatever we want. If we just want to use given information, I would list A as opposite the given angle alpha. So I'll set up sine of 37.1 as opposite over hypotenuse. And so A is 15.2 times the sine of 37.1. I'm going to make sure my calculator is in degrees. And then I could just type in what I've written here, 15.2 sine of 37.1, close parentheses for good habits. And we get 9.17 for three significant figures. We don't want to lose 1,000,000 points, so we're going to make sure that we include the units with our answer. At this point, we have options, which is always bad news. At this point, we have options. Actually, at the previous step, we had options as well. Since I had the hypotenuse, I could say A is adjacent to beta, and I know angle beta. Since I have two sides, I can use the Pythagorean theorem to find the third side. Or since I'm using trig functions anyway, I could set up cosine of, to find B. B is adjacent to alpha. So the cosine of 37.1 is adjacent over hypotenuse. To three significant figures, that'd be 12.1. Scoring for a problem of this type, since I've asked you for three different things on one big problem, scoring for this problem would be 12 points. And it would just be kind of how you would guess. 10 points for the angle and 1 point. No, I'm just kidding. It would be 4 points for each of these. Other risks, since the sides have units, the hypotenuse is 15.2 inches. There are risks for not including units, and there is a risk of doing the wrong number of significant figures. So if you just put two significant figures or your rounding is incorrect, that would be a significant figures error. That's a point. So if you did that on one or more of them, that would be an 11 out of 12. Any questions? On any, so those are overalls. And then on any one part, if you did not show your calculations, then that would also be a deduction. But make sure you show your calculations. Any questions? This is what the first page will look like. This is one of the styles of solving right triangles we had. I gave you one of the angles, and I gave you the hypotenuse. A variation of this would be I give you one of the angles, and you get one of the sides, one of the legs, A or B. The other style of problem that we have is like in part B. Flip it. Mostly. So in part B, our givens are two of the sides. So A is 21.3. And B is 17.8. So we have options about how we proceed. The most natural thing to do, I think, when we have two sides is to use the Pythagorean theorem to find the third side. And that was the first thing that was requested here. So C is the square root of A squared plus B squared. This is not the first thing that we had to do. It's probably the first thing that would occur to us to do because we have two sides of a right triangle. So we'll solve for the third side. We have to solve for angle alpha and angle beta. If the angle alpha is listed first. And in this case, I'm going to say A is opposite alpha and B is adjacent to alpha. The reason I'm going to use opposite and adjacent is that the hypotenuse in this problem has been rounded off, and I don't want to type all those digits. So I'm going to choose to use tangent of alpha. In this case, I'm choosing to use tangent because the hypotenuse has been rounded off. Hypotenuse is rounded off, so but opposite and adjacent are both given. So I'm just going to tangent inverse 21.3 and over 17.8. To three significant figures, that would be 50.1 degrees. Once we have two of the angles in a triangle, we can subtract to find the third one. That would be the best thing to do. So beta is just 90 minus the 50.1. Yeah, it's been a while since I've done this. Any questions? So as a quick note here, I chose to use tangent because opposite and adjacent are both given and hypotenuse has been rounded off. So it's not as good of a number as the others. So we chose tangent over sine or cosine since our hypotenuse has been rounded. Any question? As I Blair Witch everybody watching the screen. I'm sorry, but okay. Anybody even know what the Blair Witch Project is? Movie? Sometimes I forget. Y'all are very much younger than me, and I've been doing this for a very long time. Yay, someone knows. I just need one person to know what stuff is. So, bonus points. You know the genre of horror movie called found footage? That was one of the original found footage movies. And everybody was talking about how scary it was, and it was not scary. I did have difficulty watching it because the camera was all very shaky. It was very shaky cam, and I get motion sickness. So if you are getting motion sickness watching Trig, because I'm kind of wobbly, I apologize. If you're just sick of Trig, I mean, I can't fix that one. All right. In problem two, we switch to solving oblique triangles. We no longer have a right triangle. We are solving oblique triangles. And so I have a different set of givens. At least these ones come pre-labeled. In part A, we have one side and two of the angles. So we have two angles and a side opposite one of those angles. Since we have two angles, the smart play is to figure out the third angle first. So I'm just going to subtract the two given angles from 180. Even though it's listed second, I'm going to find it first because as soon as we know two angles in a triangle, we should subtract to find the third angle. At this point, we have a set of opposite information. I have side A and angle alpha. This is telling me to use the law of sines. So we're going to use the law of sines because I have a side and then angle opposite that side. So I'm going to set up the sine of 99.7 over 7.15. Is equal to, I can do any one of the others. I could do B first, so I'll do B first. Sine of 47.2 over B. So B will be 7.15 times the sine of 47.2 divided by the sine of 99.7. So side B is 5.32, whatever distances we're using, centimeters. We can do the same thing for side C because we have all the angles at this point. We'll use the law of sines. So C will be 7.15 times the sine of 33.1 divided by the sine of 99.7. So 715 times the sine of 33.1 divided by the sine of 99.7. Why did I go muted all of a sudden? Can everybody still hear me? Detecting me talking. 3.96 to three significant figures. Thank you. We weirdly got cut off. It's also blurry on my end, and I'm not sure why. Blurry. Any questions? Comments? Snide remark. In this case, we had two angles, and we used the law of sines to find the sides. So we did not have to worry about the ambiguous case. So hopefully that will still be true on the day of the final. Okay. In part B, we have three of the sides, so we are going to be looking for an angle. Since we have three sides, the first thing we're going to have to do is use the law of cosines. The law of cosines can be used for any of the three angles, so we'll use whichever one we remember first. So we can find angle alpha by writing the cosine inverse. Our numerator should be b squared and c squared minus a squared. If we're looking for alpha, the negative square is a. So I'll do b squared plus c squared minus a squared. Then we'll divide by 2 times b times c. And then we'll close two parentheses and start lower next time. So we'll do cosine inverse of, open the numerator, 894 squared plus 850 squared minus 850 squared. Close the numerator, divide by, open the denominator, 2 times 894 times 850. To three significant figures, that would round to 58.3 degrees. We could find angle beta doing the same thing, or we could use the newly found information if we want to use the law of cosines. Now the negative is going to be the 894. So I'm going to have 850 squared, a squared plus c squared minus b squared. divided by 2, open parentheses, 2 times 850 times 850. Then for gamma, we have two. We could have also used the law of sines. I didn't want to use rounded off information, so I just used the law of cosines again. But now that we have two of the angles, we will subtract to find the third angle. I'm writing the same number, just the spacing was really weird. So in this case, when we subtract, we end up with 58.2 degrees. If we had the other way, we could the other thing that we could have done for the third angle is to notice that side A and side C are equal. And so angle alpha and angle gamma will also be equal. So if you don't do the subtraction, if you notice that A and C are equal, sides opposite equal angles will also be equal. If you didn't notice that and just did the subtraction, you can be off by a 10. Questions? Comments? It's not a reminder. Let's pause for a few minutes here. I'll pause the video and then we'll come back and do some additional problems. As far as starting point goes, this just determines which trig function we're using, plus or minus, sine or cosine, and what the horizontal shift should be, what horizontal shift we want to use. So over here, if I think of starting at -2, -1, that's going to be a middle going up and a positive, therefore a positive sign. So I could list my starting point. This is just us making a choice. And that tells us that the horizontal shift is going to be -2. Just grab the x coordinate or the t coordinate of your starting point, and then that will be your horizontal shift. The other thing that we want to note here is that -2, -1 is at a middle going up. So we're going to write positive sign. So when we go to write our equation, f of t, a is our amplitude, that's just 4. It's a positive sign, so I don't have to put anything there, but I'll write sine. B is the pi over 12. Times t minus a -2. So that turns it into t plus 2. plus the vertical shift. In this case, that's a -1. So here's one of the equations that we might write for this function. Any questions? There are other answers that we could have gone with. If we consider as our starting point 4, 3, that doesn't change our amplitude, but 4, 3 is starting at the top, so I'd use a positive cosine. What we think of as a starting point doesn't change the period. We still always say t minus, but in this case, we're subtracting a positive 4, so t minus 4. So if we change the horizontal shift, we change what kind of function we're writing. It's going to be a plus or minus sine or a plus or minus cosine. If we start at the 10, -1, that would be a weird place to start. That's a middle going down. So we have an infinite number of answers that we can write. There are only two that actually make a lot of sense in the problem. This would be our favorite one. This one involves the point that's closest to the origin. So this one makes the most sense. So choose the named point closest to the origin. That's going to be your best choice. For part C, we're solving an equation, but instead of solving an equation by doing stuff to the equation, we want to exploit the fact that we are using that we have a graph. And in this case, if we look at the number we're choosing, the output we're trying to solve for, the -3, this is specifically chosen to be halfway between the middle and the bottom. So what we want to look at here this particular value of output, -3, is halfway between the middle and the bottom. And so what we want to use for this particular problem we want to remember that the halfway point vertically is a third of the way through the quadrant past the middle. So halfway vertically happens at 1/3 of the way on either side of the middle. This is the fast through the middle part. And so that's how we can figure out what values of t are relevant. I do have some items to return to you. I'm just going to lay the items out here. On Thursday, we will do the same thing. I will post up a Zoom meeting so you can remotely go over the problems, and then we'll just continue going over problems from the final exam. For today, pick up your old homework. Pick up the homeworks that we turned in last week. And that's it for today. I will see you all on Thursday. 3 pages of stuff to pick up, so.